So great. Let's have your questions.
Okay, so I'm looking at the WebAssign
Uh-huh.
homework and I'm looking at, oh, it just clicked out. One second. So I'm looking at question 3 and it's the using mathematical induction to prove the following statement.
Hmm.
So I got the first part of it, the show that P of 2 is true and that whole statement, but then I got to the rest of it.
Uh-huh.
And I started to get a little confused, I think.
All right. So I'm going to log into WebAssign and we're going to look at it together.
Okay,
I'm just logging in right now and I'm going
that's
to
fine.
just take a minute for me to view it as a student. So this is section 5.2.
Yes.
All right. So I'm going to go back here and share my screen.
Okay.
And here we go. So is it which problem number are you looking at?
Question number 3.
Number 3. Okay, so that's an interesting product. Uh, were you able to write that using product notation by any chance, or did you try, or are you just using the expanded form?
I don't think I wrote it by product notation. Let me look.
It might be helpful if we did that. Let's just
Okay.
take a look. Okay,
Yeah, that would be
so
perfect.
yeah, because it'll help us when it asks for things like the left-hand side of P of
Hmm.
K plus one, you know,
Hmm.
because because we always try to show uh, uh, that P of K plus one is true after we have assumed that P of K is true. So
Hmm.
it's helpful uh, before any simplification, if we're going to understand the left-hand side of P of K, is that kind of where you got lost with the left-hand side of P of K?
Yeah, I would say so.
All right, let me just stop sharing for just a minute so that we can see. So we've got this statement. It's 1 minus, what's the first factor? Is it 1 over 2 squared?
Yes. Yep.
Think about why we can't use the first factor to be 1 minus 1 over 1 squared, because 1 squared would be 1, and that would be 1 minus 1 over 1. That means that factor would just be 0, and the whole
0.
product would wind up being 0.
Okay.
Okay,
Mhm.
all right. So there's a bunch of these. And finally, if it's P of n, that means the last variable is n. So the last factor would be 1 minus 1 over n squared. That's the left-hand side. And
Mhm.
what's the right-hand side? Can you read me what the right-hand side is?
Yes. It's 1 minus 1 over k squared.
Mm, mm, That's
Oh,
that's not the right-hand side of the statement. The right-hand side of the statement, if you just go back and look up at where P of n is, it
oh,
says,
I see.
mm-hmm,
Yeah, it's n plus 1 over 2n.
okay. All right, so that's P of n. Now, uh, so when we write P of k,
Hmm.
it just means everywhere we see an n, instead, there's going to be a k. Because you see, the argument in P of n is n, and it appears here, here, and there. In P of k, the argument is k. In P of 2, the argument is 2. Like you understood that P of 2
Hmm.
is just the statement where we go up to where n is 2. So on the left-hand side, it's 1 minus 1 over 2 squared. That's the left-hand side of P of 2. It only has that single factor because the factors go up to 1 minus 1 over n squared. But if n is just 2, it just means, oh, we're just going to take this very first factor where n is 2.
Okay.
Like, it might be helpful if we look at P of 3 too, even though they don't ask us to. But anyway, let's look at, before we look at P of 3, and we will do,
Hmm.
the right-hand side of P of 2 is whatever we get when we plug in a 2, wherever the n is. So the
So
right-hand, you
it
tell
would
me.
be 2 plus 1 over 2 times 2.
That's right, which is just 3/4.
And we
And
know that that's correct because 1 minus 1/4 is 3/4. So, and 3/4 equals
exactly.
3/4.
Very good. That's exactly right. Now, P of 3 shows us even a little more because P of 3 reminds us that this is a product and we're not just taking a single factor generally. If n is bigger than 2, then the left-hand side has numerous things multiplied together. So P of 3 says go until n is 3. Include factors up to and including when n is 3. So on the left-hand side of P of 3, it would be 1 minus 1 over 2 squared times the next factor, 1 minus 1 over 3 squared.
Um, Quick question.
Uh-huh.
So how come we are doing 1 minus 2 squared times 1 minus 3 squared, and why not just start with 1 minus 1 1/3 squared?
I'm so glad you asked because what this means is we are going to take the product of all of these factors up to however big n is. That
Okay.
is the left-hand side. It's a product. So when n is 3, we take this one times this one. If we looked at P of 4, it would be 1 minus 1 over 2 squared times 1 minus 1 over 3 squared times 1 minus 1 over 4 squared.
So a good way to like look at it is to make sure so wherever whatever your P of whatever is, you go up until that to the
Yes,
left-hand side. Okay.
exactly. So let's look at the right-hand side of P of 3, just so that since we're practicing writing P of 2 and P of 3 and P of 4, and then we can check and see if they're true, just to convince ourselves. So what would the right-hand side of P of 3 be when n is 3?
Would it be 3 plus 1 over 2 times 3?
Yep, and let's just check and see if we believe it. That is 4 over 6, right?
Mm-hmm.
Which is really 2/3, right?
Yeah.
Well, let's just see. This is 1 minus a fourth, so this is 3/4, right?
Mm-hmm.
And 1 minus a ninth, which is what?
Minus
9/9 minus 1/9.
8 over 9?
Uh-huh. So let's check and see what that turns out to be. Well, that's 24 over 36, right?
Uh-huh. Which,
But we have a 12 in both of these that we can cancel, right?
yeah,
So how many times does 12 go into 24?
2,
And how many times does 12 go into 36?
3.
And isn't that the same thing as 4/6, which is what this is?
Yes.
4. Uh-huh. See, we actually need both of these to get multiplied together to get this right-hand side.
Okay.
And if n was 4 and we're looking at P of 4, we would multiply, 3/4 times 8/9 times, oh gosh, 16/16 minus 1/16 would be 15/16. And that would have to equal, well, what do we get on the right-hand side when n is 4?
Um, 5 over 8.
Yep. And if you check this, if you actually check, and multiply this out, you can do some
Mhm.
canceling. The 3 down up here would cancel with the 9 down here, leaving a 3 down here. The 4 down here would cancel with the 8 up here, leaving a 2 up there, right?
Mhm.
And so then we'd have 2 times 15, which is 30, 3 times 16, which is 48, and then a 6 can come out of both of those. How many times does 6 come out of 30?
5,
And how many times does 6 come out of 48?
8.
Yeah, and see how these are equal?
So, okay, so this actually makes a lot more sense. So this is proving by mathematical induction, and then we're proving it by uh breaking it down almost.
Yeah, these are not actually needed in our proof by induction, but it does help just to look at them so we can see what is really going on here.
Okay.
So now, P of K. Again, everywhere we see an N, we're now just going to replace it with a K. So
So,
how would we write the left-hand side?
let me see.
I mean, we don't know how big K is. We know it's at least as big as 2. We know it's not smaller than that, but it could be really way out there. So,
Um,
so you just write this,
uh-huh.
but put a K here. The
Oh, okay.
and kind of like, P of N, we don't know how big N is. Maybe N stops right there. But if we didn't write a few more of these terms in the general P of N, we wouldn't really understand even that it was a product. You see what I mean?
Uh-huh.
So we just, try to make it so that we're seeing enough to see the pattern. So on the left-hand side of P of K, what should we write?
We would do 1 minus 1/2 squared,
Uh-huh.
and then times 1 or 1 minus 1/3 squared,
Yep.
and then 1 minus 1/4 squared, and
Well,
then
yeah, but eventually, we have to
oh
stop
yeah,
writing those and get to K.
and then it would be 1 minus 1 over k squared,
Uh-huh. That's
and
the
then
le What should it equal?
it should equal the right hand side should be k plus 1 over 2 times k.
Exactly.
So let me see.
That's exactly right.
So okay.
Does that make sense?
Yes. I was wondering, so when it said one of the questions was, or the first question is to show that for each integer k, is greater than 2. If p of k is true, then I
Mm.
put p of k originally is true, but so then would it not be that? Would it be p of 2 is true?
Um, oh, you're on the right track.
Okay.
That's not quite right, but in general, if you check our notes,
Uh-huh.
in general, to prove by mathematical induction, we have two things to do. We're using weak induction, so there are only two things to do.
Hmm.
One, prove P of some low level value like 2 or 1. Here, we'll just call it N naught is true,
Okay.
where N naught represents the lowest step
Hmm.
on a stairway that's going to uh, climb up. Okay, so prove P of N naught is true for some N naught, NZ. It's usually Z plus, but we'll just say Z. And then
It's true.
we let K greater than or equal to n naught be an integer. So we just set ourselves up and we're just saying, hey, this letter represents an integer and show that P of K implies P of K plus 1. This is called the inductive step. Basically, we're saying if we're standing on step K,
Mm-hmm.
our job is to show that we can step up and stand on step K plus 1. So it's an if then. We assume this,
So it would, oh, okay.
and then we wish to show this. Our wish is to show that we can step up and stand up at K plus 1. So the bottom level value is called the basis. And then this where we prove if P of K, then P of K plus 1 is called the inductive step.
Okay.
So let's just write P of K plus 1 for this particular statement so that we know at least what we would wish. Let's see if we can figure out how to write P of K plus 1.
Okay.
Do you see how it looks a lot like P of K on the left-hand side, except we're going to add one more factor?
Yeah.
All right, let's see. It'll be 1 minus 1 over 2 squared becomes 1 minus 1 over 3 squared. Keep on going. Then there's the 1 minus 1 over k squared. What would the last factor look like on the left side of P of k plus 1?
Um,
Now we're stopping at k plus 1. That is now our n, okay?
okay.
So instead of replacing n with k, where we did, we replaced n with k in P of k, here we're going to replace n with k plus 1 here and here and here. So our last factor would look like what? We're
Um,
replacing n with k plus 1.
okay.
So it's going to look like 1 minus,
I think I'm a little confused. I'm sorry.
uh, it's okay. I'm going to show you. All right. Do you notice how the difference between the left side of P of 2 and the left side of P of 3 was this factor right here?
Uh-huh.
And
Uh-huh.
then the difference between these two and P of 4 was P of 4 went all the way up to 1 minus 4 squared as a factor, but it had the 1 minus 2 squared and the 1 minus 3 squared also.
Uh-huh.
See how we're building up and just adding on? And like P of 5 would have 1 minus 2 squared times 1 minus 3 squared times 1 minus 4 squared times 1 minus 5 squared on the left. And
Uh-huh.
on the right, we put a 5 here and a 5 here.
Uh-huh.
Well, in the same spirit, P of K plus 1 is just K plus 1 is one integer more than K. So the left side of P of K plus 1 is going to have all those factors that were in the left side of P of K.
Okay.
But it's also, am I recording?
Uh,
Okay, I think we are recording.
yeah.
But there's one more because we're going to go all the way up to K plus 1. Just like with 4, we went all the way up to 4. With
Uh-huh.
3, we went all the way up to 3. With 2, we went quote unquote all the way up to 2, but that was just the very first factor. See what I mean?
So then would it be 1 minus 1 over k squared plus k plus 1?
It's 1 minus 1 over k plus 1
Oh.
quantity squared because the k plus 1 is the n, and the n is what's getting squared down here.
Oh, okay.
See? See it?
Mm-hmm.
Now the right-hand side of P of K plus 1, well, we do just what we did when we were trying to find the right-hand side of P of 2 and P of 3 and P of 4, right? We just
Hmm.
plug in this value everywhere we see an n. So it'll be a fraction.
Hmm.
What will the top look like when we're looking for the right-hand side of P of K plus 1?
Um,
The,
so K plus one.
yep, that's
Okay.
exactly what it is. See, we're just inserting K plus 1 where there used to be an n.
And then it would be 2 times K plus 1.
Yes, two times that whole thing, K plus 1, and we have to use parentheses so that the 2 gets multiplied by the entire quantity and not just by the K. See what I mean? Like,
Okay.
see it? Like
Hmm.
we don't want just 2K with the plus 1 hanging off. We want the 2 to be multiplied by the entire number K plus 1, because that's what's supposed to happen downstairs.
Okay.
So this practice of just getting out some pencil and paper and
Hmm.
writing a few out and practicing writing P of K on paper before you try to attack what's on the screen, because it can be really confusing on the screen because it looks weird and the boxes are a weird size and everything.
Hmm.
Try, writing it down with pencil and paper and get into the habit of just substituting in K or K plus 1 wherever there is an N in the original statement P of N. And they'll give you the original statement P of N at the top of every problem.
Okay.
So shall we go back now and look at the WebAssign?
Yeah.
Okay, let's do that.
So, so I have, so for the show that, for, oh, mm, for that one I did show that P of 2 is true.
Yeah.
And then before simplification, the left side of P of 2 is, and then in that one is 2.
Uh-huh.
And then for the next blank, I said 2,
Yeah.
and then is equal to 3/4.
And you can put in, yeah, if the little equation editor doesn't pop up, you can always just use a slash.
Okay. Um, and then
Thus, P of something is true.
P of 2 is true.
That's right. That's our basis step.
Okay. And then so for the next part, I so show that for each of integer k is greater than or equal to 2, that P of k is true, then P of k plus 1 is true.
Yeah, you missed a word. You missed an important word. If
Oh, if.
If it's an if then, the inductive step is an if then. If P of K is true, then P of K plus 1 is true.
Okay.
It's an if then. It's interesting that the principle of mathematical induction is a nested if then.
Yeah.
It's like if this huge hypothesis of the principle is true, then we get to say P of n is true for all integers n bigger than or equal to whatever the lowest level was, 2 or n naught. But part of that big fat hypothesis of the principle is this if then statement that if P of k is true, then the next step, P of k plus 1 is true. So now they want, before any simplification, we need to be able to write the left-hand side of P of K.
And that's the answer for that one would be k squared. Or
Yeah, the K.
yeah.
Yeah,
Yeah.
they even square it for us, don't
Yeah.
they? All right, and then the right-hand side of P of K, and you can scroll up and look at P of N, right? We're just
Mhm.
plugging a K in there and a K in there and a K in there when we're trying to find P of K. So what's
Um,
the right-hand side of P of K?
the right hand side is K.
Yep. So, so the inductive hypothesis is that these two sides of P of K are equal. So we're going to assume that this big product, of all of this
Hmm.
actually turns out to equal K plus 1 over 2K. We're going to assume that that's true.
Okay.
Now, we must show that we can step up. In other words, we must show that what is true?
P of K or P of K plus one?
K plus 1. You see, we assume P of K is true, and then what we always try to do is show P of K plus 1 is true.
Okay.
That's what we have to show. We can't assume it.
Oh,
We assume that, see, we get that P of K is true. We assume that. That's called the inductive hypothesis, is that the two sides of P of K are equal, or that's another way of saying, hey, P of K is actually a true equation. What we must show always in weak induction is that we can step up to the K plus first step.
so okay.
So keep reading. In other words,
We must show that, well, we already wish, or the inductive hypothesis already shows both sides of P of K are equal, so it's not, it wouldn't be P of K. Would it be?
that's not what we have to show. We assume P of K was true. What we must show is that the left and right hand sides of the next step up are equal.
Would it be K plus one again?
Yep,
Oh,
that's the way it always works. We've got that P of K is true, but our desire is to show that P of K plus 1 is true. Oops, my caps lock is on. And that means showing that the left-hand side and the right-hand sides of P of K plus 1 are actually equal.
okay.
All right, I'm going to stop sharing for just a second. We'll come back to it.
Okay.
You see,
Yes.
we assume that this statement, P of K,
Uh-huh.
is true. It's an equation. When we are assuming it's true, we're basically assuming that the left-hand side is actually really equal to the right-hand side. That's our inductive hypothesis. You can go back and look at the notes and you'll see this. What we wish is always to show that P of K plus 1 is true. This is always our wish. And that means showing that the left-hand side of this equation is actually truly equal to the right-hand side. This is our wish.
Okay. So
I
the
hope
wish is with the wish to show that the left hand equals the right hand
that's right. Of 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 what?
of the equation, or like the inductive
Well, I mean, if you're all right, so here we are. We must show that P of K plus 1 is true. In other words, we must show the left and right-hand sides of P of K are equal. The left-hand side, did I say P of K? I
Oh,
meant P
you
of,
cut out for a second. Sorry.
oh, I just got a message that my internet um, is unstable because it's storming here.
Yeah, it's storming here too, so
All right,
mhm.
sorry. I'm glad you, well, it says we must show that P of K plus 1 is true, right?
Mhm.
In other words, we must show the left and right-hand sides of P of K plus 1 are equal. So if that's really our work, and it is, it makes sense that we would start with one of the sides of P of K plus 1 and try to turn it into the other side.
Okay.
Remember how we did that in class? we start with the left-hand side and we work on it until it turns into the right-hand side.
Mm-hmm.
So that's what they're doing here. The left-hand side of P of,
Uh, P of K plus 1 again?
because that's what we're working on, is, and now they want us to write the left-hand side of P of K plus 1. So luckily we already wrote that on the paper, so we know what this last factor looks like in this big product on the left-hand side.
Which is K plus 1.
Yes. And the next to last factor in the left-hand side is actually the 1 minus k squared. Remember? That's the next to last factor.
Mm-hmm.
Let me just show you. Remember, here's P of k, and it goes up to 1 minus 1 over k squared. When we write P of k plus 1, I'm just talking about the left-hand sides. P of k also has a right-hand side. But if we look at the left-hand side of P of k plus 1, if we write it like this so we can see the next to last factor, it's that one. And in fact, from here to here is the same in P of k and P of k plus 1. See all of those factors multiplied together?
Uh-huh.
Those are all the same. The only difference is P of k plus 1 has that one extra factor because we have to go up to n equals k plus 1 to get the left-hand side of P of k plus 1. But,
Okay.
but this is the term, right? This is the factor right before this factor.
Okay.
All right, so it says the next to last factor in the left-hand side is, in fact, that 1 minus 1 over k squared, which we just looked at, right? So now you read. What does it say next?
Um, so when the next to last factor is explicitly included in the expression for the left-hand side, the result is 1 minus 1 half squared times 1 minus 1/3 squared times 1 minus 1/4 squared, dot dot dot, or like last factor of the, oh, that's not the last factor. 1 minus 1 over k squared times 1 minus 1 over k plus 1 squared.
Yep, right. So see, they're writing it the way we wrote it so we could see the 1 minus 1 over k squared part.
Okay.
So this is the left-hand side of P of k plus 1 when we really take a close look at it.
Mm-hmm.
Now, after substitution from the inductive hypothesis, hang on, let's go back up and look at what the inductive hypothesis was. It is that this, when we go all the way up to k,
Uh-huh.
that it's equal to k plus 1 over 2k. That was the inductive hypothesis, that P of k is true. It's almost easier to see it on our paper. You see, this is the inductive hypothesis, that if
Mm-hmm.
we just look at the product up to 1 minus 1 over k squared, we know what that product is equal to. It's equal to k plus 1 over 2k. That can be inserted in here for this whole part
Okay.
because it's equal to it by
Mm-hmm.
inductive hypothesis. So they're trying to get us to substitute k plus 1 over 2k in for this. And then
Okay.
we'll just deal with the algebra to deal with that because it's still getting multiplied by that. All of these are getting multiplied by 1 minus 1 over the quantity k plus 1 squared. But the product of all of these is really just k plus 1 over 2k by our inductive hypothesis.
Okay. I think I understand that.
That's awesome. That's great. So now they're saying, all right, we know what this product is look like. This product really is, right? Our inductive hypothesis gave us a way to write the product from 1 minus 1 over 2 squared all the way up to 1 minus 1 over k squared. That's what they're trying to say right here. After substitution from the inductive hypothesis, the left-hand side of Well, we're still looking at P of K plus one, okay? We're
Yeah.
still trying to figure out what it boils down to. Is something times, well, the one factor that wasn't included as part of the inductive hypothesis. See, the inductive hypothesis only goes up to 1 minus 1 over k squared, right?
Mm-hmm.
So what should we put in right here?
K plus one.
That's right, because the inductive hypothesis says that the right-hand side of P of k is k plus 1 over 2k. Isn't that handy the way it's a k plus 1?
Yeah.
Times 1 minus 1 over something. Well, what goes in there?
Isn't it K plus one again?
It is, because that's that what we call the broken off factor. It's that k plus first factor. It's a factor since this is a product. It would be called a summand or a term if this was a big sum. But this
Mhm.
is a product. And now they want us to do some algebra. Okay? So they want us to get,
So it would be um on the top, it would be K plus one or K plus two.
yeah, this one, it's a little confusing. Let me show you what they're doing.
Okay.
Do you see how this is k plus 1 over 2k? It's just a single fraction right here.
Uh-huh.
But this is a binomial with a big minus sign, even though it doesn't look big, it is a
Yeah.
minus sign. What they're doing is they're first multiplying this fraction k plus 1 over 2k
Uh-huh.
times the 1, and
Oh.
then they're going to multiply the k plus 1 over 2k times the minus 1 over k plus 1 quantity squared. Get some paper out.
Yeah.
All right, so let's do this. Let's
Okay. So you said they're starting with K plus
So we've got, yeah,
one.
we're going to write it down. K plus 1 over 2k. That was the right-hand side of P of k, remember?
Mm-hmm.
Times 1 minus 1 over k plus 1 quantity squared. All right, I'm going to stop sharing so we can look at this algebra. Remember, this was the right-hand side of P of K that we used the inductive hypothesis to substitute in. Remember,
Uh-huh.
right before this step, we had 1 minus 1 over K plus 1 squared as the last factor, but before it, we had 1 minus 1 over K squared, and it was dot, 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 all the way back down to 1 minus 1 over 2 squared. Remember, we
Yeah.
started with this whole left, this is the left-hand side of P of K plus 1. It's the whole thing, kind of expanded out. Well, we took this piece of it,
Mm-hmm.
which is the left-hand side of P of K, and we substituted in this because that's the right-hand side of P of K. And
Because
yeah, go ahead.
that can represent like the left or the right hand side of P of K can basically represent the left hand side of it.
That's right, because we assumed P of K. And we assumed the left-hand side equals the right-hand side in P of K. So here we're taking the left-hand side of P of K and just substituting in the right-hand side because our inductive hypothesis is, yeah, these are essentially the same thing. And now
And
we're, go ahead.
for for the K plus one or P of K plus one, how come you wouldn't do that like oh, never mind. I think I answered my own question
It's
actually.
good to ask questions like you're asking because you want to really understand what in the world is going on.
Well, then so like how we did it for that for the first P of K, do we not do that for P of K plus one?
We can't because we don't know that.
Oh,
We're
okay.
trying to prove that. We just used our induction hypothesis between this step and this step. This is exactly where we used that P of K is true.
Okay.
Now, let's just look back at our notes. This is where paper and pencil really help. We're trying to prove P of k plus 1.
Mm-hmm.
We're trying to prove this equation is true. We are starting with the left-hand side of it. We took a look at part of the left-hand side and realized it was the left-hand side of P of k, and we put the k plus 1 over 2k in for this. So now we have k plus 1 over 2k times this broken off k plus first factor. And what we're shooting for is to get it to look like this.
I see.
We're working toward that, and we're closer than we were. Because think about what we started with. We started with all this, right?
Mm-hmm.
We started with the left-hand side. We're trying to get it to look like that. Well, we're closer to this than we were at the beginning because now we at least have a nice fraction,
Mm-hmm.
but we're shooting for k plus 2 over 2 times the quantity k plus 1. Let's keep that
Okay.
kind of where we can see it. And let's just keep our wish up here so that we know we're really trying to change, this left-hand side into that. We've gotten this far. This is now what the left-hand side looks like. It doesn't even look like the left-hand side anymore. It looks like something in between the left-hand side and the right-hand side, but it is equal to the left-hand side because we made a legal substitution here. These
Okay.
two are equal. This expression on this line is equal by induction to this expression on this line. And now we're going to keep working on this until it looks like
Like
that.
that. Okay.
So what they're doing in that weird looking step of algebra is they're saying, okay, we have a fraction, k plus 1 over 2k, and now we're going to distribute that because it's being multiplied times this
Mm-hmm.
binomial. They take it and they multiply it times the 1 minus this times the 1 over k plus 1 quantity squared. So let's do that with just pencil and paper, okay?
Okay.
What's k plus 1 over 2k times 1?
Two k plus 1 over 2k.
Perfect. Minus, and I'm going to write it out, k plus 1 over 2k times 1 over k plus 1 squared. Do you agree?
Yes.
Now, they're not going to show this intermediate step, I don't think, because look at what this is. It's a fraction
Mm-hmm.
times a fraction, but there's a factor up here, k plus 1. Oh,
You can cancel one of them, cancel the k plus one of the k plus.
that's right. And now we just have one of them down here. So I think they're going to jump directly to k plus 1 over 2k minus 1 over 2k times k plus 1. I think that's what they go directly to. I think they skip this canceling step, but you really kind of need to do it on paper to see. Let's go back and look and see if that's what they do.
Okay.
Okay, so they multiply the k plus 1 over 2k, which is right here,
Mm-hmm.
times the 1 to get k plus 1 over 2k. Oops. Minus, yep, they did it, 1 over 2k times, well, if you can't remember what we got 1 over 2k times that other copy of k plus 1. Isn't that funny the way it always is turning out to all be k plus 1?
Yeah.
So funny. And they don't always turn out that way, but I think this is a really good problem because it really does turn out that way. It's just like all these k plus 1s everywhere. And then they combine by getting a common denominator. See how this is a fraction minus a fraction?
Uh-huh.
And one of the fractions has 2k as a denominator. The
Mm-hmm.
other fraction has 2k times k plus 1 as its denominator. So 2k times k plus 1 is the common denominator, right?
Okay. Yeah.
So to put k plus 1 over 2k times k plus 1, we have to multiply it times k plus 1. All right, hang on, I'm going to write this down so that we can look at it. All right, so they're here, and then they go somewhere else. They get a common denominator, right? Because we have a fraction minus a fraction, we want a common denominator, and this is the common denominator, right?
Mm-hmm.
All right, so the k plus 1 is over 2k, but it wasn't over the k plus 1, so we have to multiply this k plus 1 times this k plus 1 to get k plus 1 quantity squared. Do you see that?
Um,
Let me just see if I can show it to you. Let's say we have 3 over, I don't know, 8 minus 1 over 8 times 3. Okay? What's the common denominator of
oh,
these
we're
two?
trying. I see. I was just confused. I didn't realize that it was already jumping that far. So
Yeah, it's going way far. But the thing is, I think they probably even expand this and cancel the plus 1 and the minus 1. Because if you expand k plus 1 quantity squared out, like we can't cancel this with that. You can't do that.
yeah.
But if we expand the numerator, that's k squared plus 2k plus 1, right?
Mm-hmm.
Minus 1. And down here we have 2k times k plus 1. So the plus 1 and the minus 1 cancel, right?
Mm-hmm.
So up top we have k squared plus 2k. On the bottom we have 2k times k plus 1. And let's see, can we factor anything? I think that's it. Well, wait a second. Something's got to cancel.
The 2K, can the 2Ks cancel? Or
No, like, but oh, we can pull a k out.
oh,
K times k plus 2 up top, right?
uh-huh.
And then 2k times the quantity k plus 1 on the bottom. The k's can cancel, and that leaves us k plus 2 on top over 2 times the quantity k plus 1 on the bottom. And that was what we wanted. K plus 1, right?
Mm-hmm.
Over 2 times the quantity k plus 1. And that is the right-hand side of P of k plus 1. You really got to use some pencil and paper on the side because some of this algebra is a little tricky.
Yeah.
But I think your algebra skills are actually fairly decent from what I can tell.
Oh, thank you. So that
I'm not
um
sure whether I think they go to this probably.
the
Well,
bottom,
well, wait a minute. Does the bottom have the K in it still?
yeah,
All
yeah.
right, so they probably go to either this or this, or they might even accept this. They might even accept this. Like I don't, you could try because this is the most natural thing, right?
Mm-hmm.
We're getting a common denominator. So it's k plus 1 quantity squared minus the 1 that's already over. You could try, let's try putting in that and see if it accepts that.
Which the
Let me
denominator has
see. Oh, go ahead. Just what does the denominator have in it?
it's 2K times K plus 1.
All right, so I think it might be k plus 1 quantity. I want to do an exponent. So what do I have to do? This? No, that's the wrong thing. Wait, I think I have is this a fraction?
Um,
What the
like
heck? I gotta just delete all this. That is a mess. Can you use a caret for a fraction? Will it let you do this? Will it let you say k plus, I mean for an exponent, I said fraction. Can't,
Yeah,
well,
yeah.
let me use a carrot like
Yeah, it does.
squared. Oh, if you just hit the carrot, then it puts, and then you got a cursor out of it, and then it was -1. So,
And then I
so
think
go ahead.
oh, I think the next one is the
Before simplification, the right-hand side. Oh, yeah, that was before we simplified it. If we go back and look, this is before it's simplified, right? Where we just put in k+1 here and here for the n,
hmm
k+1. Yeah, so I think they want this before it's simplified.
Oh, like put that as the right hand side of P because I thought it was before simplification. The right hand side of P plus one is K plus one over 2 times K plus 1.
Yeah, I think that is. I think it is k+1 over 2 times the quantity k+1. I think you're right.
Okay.
Because that is what we have before we simplify it. So let's put that in there. Is I'll put, and you don't really need parentheses around it, but it's not wrong to put parentheses around it, you know.
Yeah,
I don't
that's
think that they'll count as wrong. And when the right, left and right hand sides of P of, well, still k+1, of course,
yeah.
that's what we're working on. K, k+1 are both simplified. They can both be shown to equal. Well, let's simplify the right-hand side. It's easier, right?
Yeah.
So if we do a fraction, then what is it? K+2
Yeah. Over
over,
2 times K plus 1.
and that is what we get because the k's canceled and we had k+2, right? I mean, this k canceled and this k canceled and we had k+2 over 2 times k+1. Yeah.
Oh.
So that this is the simplified version right here that they both go to, the simple right-hand side. Of course, when we write the proofs by induction for the special homework, you're going to go all the way down to make it look like, or you could work on one side for a while and work on the other side for a while and show that they meet in the middle. That's kind of what these guys are doing.
Okay.
Let's see what else happens. Hence, P of k+1 is
K
true,
plus 1, yeah, okay.
which completes the induction. All right, I'm going to submit my answer and see if we did it right. Hey, look at that. And it's such a funny little problem. You know why it's so hilarious, Elise? They don't always turn out to be so many k+1s everywhere,
Uh-huh.
but this one does. So I think it's just a really smart little problem to put as one of the first problems where you really have to work through the induction algebra
Mm-hmm.
because before, it's they're kind of doing more just like calculation stuff up here, right?
Mm-hmm.
And this is the one where you really have to start digging in. And then this one is more of sort of a calculation thing. But so you'll just do it on pencil and paper and figure it out.
Yeah.
And then, oh yeah, oh, here's one of these problems like we did where we used that formula that we proved.
Mm-hmm.
And we want to see 1 plus 2 plus 3 plus 4 plus dot 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 plus n.
Mm-hmm.
But when they're spaced out like this, where like there's a difference that's bigger than 1 between them, remember what the trick was?
You start at and you don't start at and not
Yeah, because what's the difference between 4 and 8 and the difference between 8 and 12 and the
4.
4? So you don't start it in naught. You pull a 4 out of this thing, factor the 4 out. And
Mm-hmm.
when you factor a 4 out of 4, it leaves a 1. When you factor a 4 out of 8, it leaves the 2. When you factor the 4 out of 12, it leaves the 3. So it'll
Mm-hmm.
be 4 times 1 plus 2 plus 3 plus 4 up to, I don't know, whatever we get when we divide 120 by 4.
I think it's 30.
I think it is 30. And then you can use the formula for 1 plus 2 up to plus 30, you know,
Mm-hmm.
use the formula for that part and then just multiply by 4 because you pulled the 4 out.
Yeah. Oh, I almost forgot about that.
Yeah, those are fun. I like those.
Yeah.
I think those are fun. And
Yeah.
I think down here, I think did I give y'all one where yeah, I meant to give you, is this all? Is it?
Yeah, there's only six
Oh,
questions.
boo. I meant to give y'all one where you had to do, I thought darn it, I thought I gave y'all another problem, but where you had to do a little more, but I gave it to you on special homework, right?
Oh, yeah, I looked at the special homework and I'm gonna get
Okay.
started on
Well, I
that.
think that that was definitely the hardest problem in
Yeah.
this 5-2 WebAssign. So attack the special homework, and
Mhm.
then are you around tomorrow between 3:30 and 5, or are you around Tuesday from 5 to 6?
Um, I have to work tomorrow, but I might be able to get off early.
Okay, or we could maybe do a Zoom
Okay.
later in the week, like maybe on Tuesday or Wednesday morning.
That would be awesome.
I'm so sorry about Friday
That's
night.
okay.
Yeah, thank you for being so understanding about that.
Absolutely. Yeah, I'm just happy for the help. So,
Okay, well, I think that we made good progress here tonight.
me too. I'll send you an email probably later tonight or tomorrow morning about meeting.
Okay, and part of what I have to do is wait for an email from one of my superiors. I can stop recording now.
Okay.